Question number 3.122. In this question, a circuit is given that comprises of two capacitors. One is capacitor C1, another one is connected here, capacitor C2. Now these two are connected across a battery with EMF E. Okay, there is another battery of same EMF and there is a switch S which can move up to this point, and two paths are marked here, path 1 and path 2. Now the question is stating that what charges will flow after sorting of the switch, this SW, from position 1 to position 2. Okay, and we have to measure the flow of charges through path 1 and path 2 according to that the direction indicated by the arrow. Okay. So look, first we need to check that total amount of charge is stored in this circuit when this switch is open. Okay, so right now if this switch is open, let me mark the first condition, when switch is open. So this EMF is not the part of circuit. So C1 and C2 are in series. So net capacitance would be C1 C2 over C1 plus C2. And it is subjected to a voltage which is E. So net charge is stored in this circuit Q is equals to C1 C2 over C1 plus C2 into EMF. This is total charge stored within capacitors when this switch is open. Now, if this switch is closed, then this EMF will become part of this circuit and that will try to maintain a potential difference across this point. Okay. So the capacitor C2, now next condition is when switch is closed. So when this switch is closed, then the capacitor C2 is in parallel with this EMF. Okay. So it means there will be some charge stored in this capacitor C2. That is, let's take Q2. Okay. Q2 is C2 into E. Secondly, if we look at this capacitor, then one end is subjected to one battery with EMF E1. Another is also having same EMF. So there is no potential difference across the terminal of capacitor C1, right? So the charge stored in capacitor C1 after switch is closed is equals to 0. Okay, so initially there was charge C1 plus C2, C1 C2 over C1 plus C2 into E before closing the switch, but after closing the switch, this charges Q2 E2 is C2 into E and Q1 is equals to 0. Now if we'll try to figure out charge flowing in this direction 1. So it would be sum of charge Q1 plus charge Q2. So from path 1, net charge is Q1 plus Q2. Q1 is 0 and Q2 is C2 into E. So through path 1 there will be a charge C2 into E. Now from path 2, which is going in this direction. So after closing switch there is charge Q1 what we have assumed, and initially there was charge C1 C2 upon C1 plus C2 into E. So if we'll consider this charge greater, although we know this is equals to 0, but we have to measure charge according to this direction, then the charge flowing through path 2 as marked in this figure is equals to Q1 minus Q. Okay. So Q1 is 0 and Q is already calculated before changing the position of switch C1 plus C2 into E. So charge passing through path 2 is minus C1 C2 over C1 plus C2 into E. So this is from path 1 and this one is from path 2.